My name is Solutions Architect at AWS, and I think today we have a particularly interesting topic that we're going to discuss in some depth. We're going to be sharing some best practices around how we see businesses and our partners achieving continuous integration and deployment on top of AWS as they're building their platforms. A lot of our more mature customers are looking to automation to achieve business outcomes, and so today we're going to not just share some of those best practices, but we want to demo some concrete examples of how you might go about doing this kind of thing for your businesses as well. So to that end, we'll be showing you some tool sets and tool chains in the hope that you can take some of these ideas away and apply them in your respective environments. So if there are three main things that I'd like to leave you with today, it's that there are some very good business drivers for looking at something like continuous integration and deployment, generally speaking. And so throughout the rest of the deck, I hope to show you that a well-designed and properly implemented CI/CD pipeline can dramatically affect these three dimensions across everything from your development lifecycle through to how you manage and release your software for your customers. So we're going to be talking about ways of reducing the risk of change to free up our development teams to innovate and experiment. We'll be talking about ways of automating tests and other checks and balances to improve the quality of the software that we're changing and releasing. And we'll be talking about a particularly interesting topic that our largest customers want to know more about, and that is particularly in a world where on the AWS Cloud they can deploy infrastructure very quickly, they can scale up and scale down that infrastructure. Those customers want to build a compelling governance model and framework around how they manage that change. And I think continuous integration and deployment provides that while still maintaining flexibility to move quickly. So let's refresh and have a quick look at what a CI/CD workflow typically looks like. Many of you will have implemented something like this or a subset of this perhaps in your respective organizations, but we'll take it from the top down. We always have actors or agents in the system represented on the left here. These are typically developers or project managers or team leads, even product owners that are interacting with a issue tracker of some sort, which tracks work to be done. So this could be, an example could be Atlassian Jira, for example. And we have developers interacting with the source code management system as well. And they are contributing changes to that source code management system, versioning their changes, being able to provide an audit trail for those changes and what have you inside of that system. But if you look at the center of this workflow, and this is really the engine room, if you like, of the workflow, we have the CI/CD tool. And this is responsible for orchestration, and it integrates with all the other pieces in this workflow. So it certainly knows how to integrate against the issue tracker. It knows how to pull source code out of the source code management system. There's even a feedback loop between the source code management system, the tool, and the issue tracker, such that during a build, if we see a test failure, we can push that status back to the issue tracker, and a developer responsible for that change can pick that up and fix it. But where it really gets interesting is when we start calling out to other systems to do things like automated tests. So today we'll be talking about ways of automating test harnesses. And then we'll also, of course, be talking about the value that a lot of the automation tools on top of AWS bring around deployment. And so the end result being that we have a new stack or a new environment or a new version of our application deployed in a completely automated fashion. If we want to make this workflow more concrete, I've just chosen some tools here that I think are we see in the industry fairly frequently and are potentially best in class. For the source code management system, we're talking about Git. Today we'll actually be using GitHub, but we could be using Git behind the firewall, either with proprietary systems, commercial systems like Atlassian Stash, or Git servers that we've built behind the firewall ourselves. The main tool chain today that we're really going to focus on is Bamboo. And Bamboo will be the orchestration tool. And it's going to be extended with a plugin called Tasks for AWS. That's one of the powerful features of Bamboo, is that you can extend functionality through a marketplace of plugins. And so we're going to use Tasks for AWS to give Bamboo a much richer view and insight into AWS. So Tasks for AWS will be responsible for talking to DynamoDB, the simple storage service for storing our build artifacts, CloudFormation to do the deployment and the automation, and so on. And then Bamboo also will be orchestrating the unit tests that we'll be running today as well. So I wanted to couch this whole discussion in terms of a pipeline, and this will be familiar to many of you. And I think the 5 stages in this pipeline that we've represented here are fairly indicative of what you're trying to achieve with CI/CD. So we start with code, of course, and that is where we have developers and development teams contributing code and changes, perhaps brand new features, or they're fixing bugs, for example. We have, after code, a test stage, and the test stage is a gate. So we try and automate the test stage as much as we can, and if that gate isn't passed, then the entire pipeline stops. Okay, and that's one of the first checks and balances in the CI/CD pipeline. So if tests fail, we don't go through to deploy. If tests do pass, then we go to the deploy stage. And what we're talking about with deploy today as a stage in the pipeline is the process of building an artifact for deployment. Okay, I'm not necessarily talking about enacting that change in a target environment. I'm talking purely around packaging a change into a deployable unit for release. The next stage is the release stage, where we make that change real in a target environment. And then the final stage is effectively completes the life cycle for the artifact that we'll be deploying. That's teardown. And this is really important. This can often get forgotten. But teardown is important, especially when we're doing some sophisticated automation, because we could be standing up assets and infrastructure that we need to also manage the life cycle of. So once an application version has been outdated and we're ready to go to the next application version, we do need to carefully think about how we're cleaning up after ourselves in terms of the AWS resources that we've been using. Let's have a look at the first stage, which is code. Here I'm representing on the screen a branching model, and the branching model is called feature branching. It's also commonly known as Git flow, albeit this is a very simplified version of Git flow. But it's important to understand that a branching model or a branching strategy that you employ in your source code management system can dramatically affect how successful your CI/CD pipeline is. And I'm making the case here that feature branching is very well suited for the kind of automation we'll be talking about today. So here I have 3 branches. I have production, UAT, and a feature branch. And you can see feature branch has been branched off UAT, so it's downstream of UAT. And we're going to branch out into a new feature branch so that we can isolate the work that we're doing in that branch. And another way of putting that is we can contain the risk of a change that we're making for a feature within the branching model. So what does that really mean? It means that we can work in isolation, in a completely isolated branch, a separate branch, and make changes, and potentially destructive changes, things that would potentially break the application. And we can do that without impacting UAT. So that's the first point to be made here. We're containing risk of change in the branching model. And what does this do for your development teams? Well, this encourages them to branch early, to branch often, to experiment. It gives them the freedom to do that without the risk of impacting other streams of work. And we're encouraging our development teams to branch as many times as they need to while they're building features. The other point to make on this diagram is every blue disk in the branches here is a commit, represents a commit in the branch. And what you can see is we're running the same pipeline over every single commit. So every commit on every branch here is being run through the same pipeline: code, test, deploy, release, teardown. And this is critical. This gives us repeatability, predictability. It lets us inherit the test effort in feature branches in higher order branches. So if we flesh out the test harness in the feature branch, we can then inherit that work in UAT and so on. And this will slowly improve the quality of the code and the software that we're contributing over time. But this is really important. I think if we're not doing this, then we're missing one of the main points of CI/CD, which is the same pipeline is run over every single commit in every single branch. One of the challenges, though, when we implement something like feature branching, especially in a large organization where there are lots of changes happening at any point in time, is that we could end up with many, many feature branches. And the complexity of managing potentially conflicting changes across those different feature branches becomes material. And so we need some strategies to help simplify that. So here I've represented 2 feature branches, both branched off UAT at some point. And you can see the feature 1 commit is merged back upstream into UAT before feature 2 is. Now, imagine a scenario where 2 disparate teams are working on the same code base, both iterating quickly, both experimenting, and they're both working on potentially the same piece of code. We could end up with a conflict across those 2 features. Now, that happens all the time. And in the traditional model, we would capture that conflict when the feature 2 commits are merged back up into UAT, and we would capture it in the UAT branch, and we'd manage the conflict there and resolve it, and so on. The problem with that model is when we have lots and lots of features in flight, and we have lots of potential conflicts being merged back into higher order branches like UAT or production, we're introducing risk there. What we really want to be able to do is take that feature 1 change and push it back down into feature 2. And that's what we're doing here with automated merging. And in fact, the screenshot on the right-hand side here is a screenshot of a Bamboo widget where we've just had a checkbox where we can enable this feature. So what happens in this model is when feature 1 is merged into UAT, then the CI tool automatically pushes the change back down into the feature 2 branch for us. And now that means that we're moving the risk of that conflict and that resolution work far away from a branch or an environment we care about, back into a feature branch, again utilizing the feature branching model to contain the risk of that change, and we're running the same CI/CD pipeline over every commit, and we're able to manage that risk much more carefully. So let's have a think about what CI actually gives us. We're absolutely focusing on promotion through tests. So we're never able to promote a development change without it having run through automated tests. And this is critical. There's no way of circumventing a test harness if we've done our CI/CD pipeline correctly. And so that's a big one. That can help us raise the bar in terms of quality. What we're also trying to do is, through automation, is fail fast. So we're trying to get feedback from the test phase as quickly as possible and feed that back to the developer. And if we're integrating with task tracking systems in our CI tool chain, we can get a very nice workflow happening there where a developer is able to get that feedback really quickly. And as our development teams iterate, we're able to in many cases, increase the rate of the development. We've talked about containing the risk of change in the branching model. That's important from a source code management strategy perspective. We're automating tests to find bugs as quickly as possible, and through automation trying to reduce human test effort as well. So let's make this a little more real and have a look at an actual implementation of a CI pipeline. So I have a Bamboo environment that I've set up prior to today, and I have 2 different pipelines in here. So I'll spend a little bit of time explaining what we're seeing here on the screen. Bamboo has the concept of projects, and inside of those projects, it has the concept of plans or build plans. I have 2 build plans here. One is the data sources pipeline, and one is the web application pipeline. The data sources pipeline is responsible for managing my database changes in a completely automated CI/CD pipeline. So we'll actually be demoing that later today. We'll be making a schema change to a database in a completely automated way through this pipeline. But the web application pipeline is one that we're probably more familiar with. This is responsible for taking changes out of a source code management system, packaging them up, running some tests over those, and deploying those to a target environment. So what I'm going to just show you here is a pipeline that I've already run. And this pipeline is actually in production. So if we look at the pipeline and the stages in that pipeline on the left-hand side here, we can see some stages here that reflect really closely what we've already been talking about. We have a test, a build, a release, and a teardown stage. The test stage is the one that we're most interested in. And this is where we've automated the process of running our test harness over a build artifact. And so in this case, we have a Python Flask web application that we're hosting. And this is what the Flask Python web application looks like. And this is, in fact, the URL for the automated build process that we've just displayed in Bamboo. But if we go back to the test phase and look at logs in Bamboo, we're able to see all the work that was done in this stage and the tasks in this stage. And you can see here that I'm running an application test harness that I've defined as part of the test phase, and I'm running 5 unit tests. So this is a fairly synthetic example. If this had failed, the entire pipeline would stop, and I wouldn't go to the next stage, which is build. So we'll cover this in more detail as we go through the CI/CD pipeline, but this is a simple sort of check and balance, or a gate, if you like, that you should implement in every single pipeline that you build so that you're sure that you're maintaining quality when you're pushing changes through. Okay, so the rest of the time that we have together, we're going to spend talking about continuous deployment. And this is actually probably the most complex part of a CI/CD pipeline. This is where I guess the most complexity certainly creeps in. So let's have a think about what we want from continuous deployment, and then we can start thinking about ways of achieving that. Continuous deployment is meant to help us push changes really quickly to a target environment. Ideally, we certainly want to treat production just like any other environment. We want to avoid treating certain environments specially, and we'd love to actually treat production just like any other application version. And so we'll be talking about ways of doing that through the rest of the talk. We want to do this to get immediate feedback from users. And if possible, what we'd love to do through our continuous deployment implementation is support the ability to have multiple versions of our application in production at the same time, and have a portion of our customers or our user base being sent to one version of the application and a portion to the other, which then lets us do things like A/B testing, where we can run analytics over a version of our application and gauge the success of a feature change, and use that feedback to fold that back into the development lifecycle and further improve our applications. What we're also trying to do is automate this completely and do this very often over every single commit in every single branch. Now, the outcome of that approach is that we're running the same process time and again and again over every single commit, and that's de-risking the deployment process. There is nothing special about the deployment process for a feature than there is for the deployment process for a production release. And hardening the deployment process in this way gives us a much greater level of assurance that when we go to push out changes in production, that there are going to be no surprises. In fact, we want the continuous deployment process to be completely unsurprising, and certainly to be able to be done through business hours. And again, because we're able to do this quickly and automate this process and have multiple versions of our application in production, this gives us a breadth of data points that we can use to further improve the customer experience. So AWS provides a number of application management services, and I'll talk through these really quickly. I'll spend really most of today talking about CloudFormation as the main automation approach, but it's worth talking about the others. Elastic Beanstalk provides an application-centric approach for managing your application and deploying your application. So Beanstalk manages the underlying infrastructure and also a catalog of your application versions. It understands to a degree your development lifecycle. It knows what an environment is, it knows what an application version is, and it can roll forward and roll back and redeploy a same version of your application. So it does quite a bit of work around the application lifecycle. And the value add here is that a developer thinks purely in terms of their application. They can sit in their IDE, be it Visual Studio or Eclipse, for example, using the AWS Toolkit integrations, which then natively call out to Beanstalk and just let them deploy their application quickly without worrying about auto-scaling and multi-availability zone architectures and load balancing and so on. OpsWorks on the right of Beanstalk there gives you a little more control. And so what OpsWorks lets you do is define exactly what your application stack looks like, and within your application stacks, what the different application layers or roles of servers in the application are performing. And so this lets you define, say, a load balancing layer, a presentation layer, an application layer, a database layer, and so on. And then when those layers are built by OpsWorks, you can use industry standard configuration management tool chains like Chef and Chef recipes to be able to customize and bootstrap those roles in your application architecture. If we go across to Code Deploy, this is a very new service that we just released at reInvent several weeks ago. What Code Deploy is trying to take off your hands is the complexity of deploying your application artifact to a fleet of servers. Okay, so what it's trying to do is automate deployment as much as possible so that you then think about your application lifecycle and your application features. And I'll talk a little more about this in the next few slides. The main automation approach that we'll talk about today is CloudFormation, which gives you even more control again and lets you templatize your infrastructure on top of AWS. In fact, this is what we're going to be demoing in the Bamboo environment and showing even database schema updates via CloudFormation. So we have some more advanced topics to cover around that. If we look at, broadly speaking, deployment approaches generally, we have two, really. There is deploy in place and building discrete environments that we stand up for the purpose of hosting a new application version. So at the top here, I've represented a load balancer with an scaling group of EC2 hosts behind it. It's a very trivial one-tier application architecture. And what we often want to do for a deployment approach is reach into each host behind the load balancer, probably disconnect it from the load balancer or drain connections using ELB connection draining, deploy our application update inside the host, sanity check that, and then re-enable the connection to the load balancer, in which case the load balancer continues to balance traffic to it, and we roll that out across the fleet of servers. Okay, and so there's a somewhat sophisticated workflow happening behind the scenes here in terms of managing interruption, but what it's giving us is the ability to turn around changes really quickly, so we can deploy application updates in place without having to wait for servers to start or infrastructure to be provisioned on top of AWS. The other approach is to stand up a brand new discrete environment, and this is actually the one we'll spend most of the time talking about today. What this gives us is the ability to roll forward and roll back really convincingly. So what we have here is a BlueStack that is our existing application version, and we will stand up a completely identical environment that is completely isolated from the blue environment, and we'll call that the green environment, and we deploy our new version of our application to that. And so what that means is while production traffic is still flowing through the blue environment, we're able to, in isolation, test the green one, make sure that we're happy with it, scale it appropriately, do load testing, again, in complete isolation without impacting our other blue environment. And when we're ready, we can flip to the green environment and turn on that version of our application. The really powerful approach here is when we need to roll back, we can just easily flip back to the BlueStack. So rollback here is probably easier than the deploy in place option. AWS Code Deploy is actually a service that tries to help with the first deployment approach. So basically reaching in and deploying to a fleet of servers on your behalf. So what its goal is really trying to achieve is it's giving you centralized control over your deployment lifecycle, where you can define hooks in that deployment lifecycle. And it will manage how those changes are rolled out to the fleet of servers in a completely automated way for you. So if we look at something that you might have deployed on top of EC2, you would have a fleet of servers that you need to be able to update. So Code Deploy can do that on your behalf. It can also use auto-scaling as well. It understands how to interact with auto-scaling, and it also understands how to do this across different environments consistently for you as well. If we think about some of the controls that Code Deploy gives us, it allows us to define the footprint of servers that we deploy to at any one time. So, for example, it supports deploying to a host one at a time in a fleet. So if we had 4 servers behind a load balancer, we could tell Code Deploy to only update one at a time and carefully manage interruption at the same time. We can deploy using heuristics like half at a time. Or all at once if we're happy for the entire environment to be interrupted. So this is kind of the control that Code Deploy gives you around managing interruption and speed of deployment. Probably one of the most powerful things about Code Deploy is its product integrations. So it not only supports just about any application framework, be it .NET, Java, Python, Node, PHP, and so on, and Linux and Windows infrastructures, but it also lets you reuse setup scripts that you might have already built. So you may already have PowerShell or shell scripts that you've built to bootstrap and provision parts of your application. You can reuse those and hook those into the Code Deploy lifecycle. It certainly lets you even leverage configuration recipes using Puppet or Chef, for example. So we acknowledge that you have an investment in how you're deploying your applications today, and Code Deploy tries to be flexible to let you reuse that investment. The other thing that I'd say is the ecosystem around deployment and configuration management is also doing some nice integrations with Code Deploy. So we have GitHub and Atlassian and Jenkins and Travis CI, and the usual suspects here that are providing some really powerful continuous integration deployment tools already in the marketplace, being able to leverage Code Deploy as a deployment methodology. So the other approach that we started talking about was building discrete environments. And one way of packaging up your application change for a discrete environment deployment is to use what we call AMI baking. Okay, so what I've represented here is a process that we have built into Bamboo to bake an AMI, and what this will end up doing is taking our application change, bootstrapping it into an EC2 instance, and then imaging that as an Amazon machine image, And then our unit for deployment, or our artifact that we're going to deploy, is no longer a tar gzipped file or a WAR file or an archive of some sort. It's actually a complete Amazon machine image, which completely describes the machine on EC2. So the way that we do that is we spin up a builder instance on EC2, we bootstrap it, and we're going to use CloudFormation Init there to do the bootstrapping work and configure our application on the host. We'll just use EC2 create image to bake the AMI, and then we'll tag it, and we'll tag it for reporting purposes and perhaps cost remediation. And once we're done with that, we'll clean up the builder instance. So the builder instance is only around for the purpose of generating an image, and that image will then be used to start servers with our new version of our application on it. So this is, on the right-hand side here, the fully baked approach, where we're baking everything into our AMI. Now, there are different levels of baking, and you don't need to bake everything into the AMI. You may choose to just bake your platform and framework and web environment into the AMI and then bootstrap your code at deployment time. But to simplify deployment, and certainly to speed deployment, we're going to bake everything. And also what this gives us is an immutable artifact. An AMI can't be tampered with or changed, and we can then go back and look at exactly what was deployed at any point in time and reference that for audit reasons, or perhaps just to roll forward and roll back to different application versions. So it's a simple approach, but has some really nice benefits there. CloudFormation Init is the process that we use to bootstrap our host. And so here I have a really simple example of CloudFormation Init in a CloudFormation template that uses standard package managers like Yum to install services like Apache Web Server here, to lay down files on the file system and pull those from S3, from an S3 bucket that we own, set permissions on those, and even set up services to start at boot. Okay, so this is a very trivial example. Your bootstrap process is undoubtedly more complex than this, but CloudFormation Init can do a lot of that heavy lifting and a lot of that complexity for you. Many of you that are using Puppet or Chef to do this kind of configuration work will probably see familiar ideas and semantics in the CloudFormation Init code that I've just showed you, but that's what we're going to be talking about and using today. So let's have a look at a continuous deployment pipeline, and we're going to look at two. We're going to look at the data sources pipeline and deploying a database change, and we're also going to look at the web application pipeline and deploy a new version of our web application to a completely discrete environment. So let's go back to Bamboo here. And what I'll do is go back to my AWS Lab project and go to my data sources pipeline this time. And what you'll see here is that I have a data sources pipeline that's already run. And what this pipeline has done is actually, when it was first run, has created a MySQL database for me, has set up the schema on that database, and has even done some data import work. And a lot of the complexity of that effort has been outsourced, if you like, to Liquibase as a database schema versioning framework. So if we look at the stages inside the pipeline, we still have a test stage, and we have a deploy stage, and we have a teardown stage. The test stage is responsible for building a CloudFormation template which deploys a change to our database. And in fact, what it also does is syntax checks the CloudFormation template is generated. And we're using a Ruby DSL to generate the CloudFormation template here because we need that to be dynamic. And then the deploy step uses CloudFormation and the template that we've generated in the previous step to go and enact that change, either by building a brand new database for us if one doesn't already exist, or updating the existing database with a change log. And that change log is a Liquibase change log that we've built into the CloudFormation template in the previous step. So what we're going to do here is make a database change. And so I'm going to put my developer hat on and jump across to the command line because, like all good developers, I live and breathe the command line interface. And this is basically a development environment. And if we look at what I have here, I have a checked out Git repository called Sign Up Data Sources. And I have a couple of branches here. Actually, the branch that I'm in is the age collection branch. And so what I'm going to do is I'm going to connect to the existing database for you. And I'm going to show you what schemas have been deployed. We have a users table, and we have some other tables there that are related to Liquibase. What I want to show you is how easy it is. Oops, I'm sorry, I've just disconnected from my session. What I want to show you is how easy it is to deploy a change. So I'm going to basically take a Liquibase changelog, which I've already built. So this is probably the fastest development I've ever done in my life. But the changelog is going to represent a schema update, and I'm going to commit that, and I'm going to push that commit to the remote origin, and that remote origin is on GitHub. And if we wanted to look at the changelog, we would see that the changelog contains a brand new schema definition. It basically contains a brand new table that we're going to build in our database. So if we go back to Bamboo here, Bamboo has been configured to automatically watch commits on the branch that I've just committed to. And so it'll take a little bit of time, but eventually what we'll see is a brand new build kicking off. And so this is running our data sources pipeline automatically based off the commit that we've just pushed from my development environment. And if we go into that running build, we can see that the CloudFormation template has already been constructed and syntax checked and passed. And so our first test gate is successful. And now what we're doing is we're deploying that change. Okay. And so we could tail the logs in Bamboo here, eventually when there are some to tail, and we could watch exactly what CloudFormation is doing, because we're using tasks for AWS as a plugin that gives us really good rich feedback and integration against CloudFormation here. So what we'll do is we'll wait for this to update, and I'll jump across and show you the CloudFormation template. So the CloudFormation template we saw very briefly there was updating, and this is our fast sign-up data sources template. So what we did was the pipeline realized that we already had a database. It generated a CloudFormation template, which was an update, and then it applied that update against the existing CloudFormation stack, and that used Liquibase to update our database schema. So we can see if we go back to Bamboo that our deploy stage is complete and green, and we're paused at the teardown phase. Now, the reason we're paused is we've made this a manual stage. We can see a play button here, which I won't press, because what that will actually do is remove our database environment, which is probably not what we want to do right now. But there are some nice access controls around how we can give people access to do that kind of function. But let's actually see if this has made any change to our database. So we'll go back and connect to our database again, and then we'll show tables. And what we can see here is a brand new table, which is the blogs table. So we could also then do a select from blogs table, and we can see that we've also already imported some data into that blogs table. So what we've done is update the database in a way that doesn't break the web application. So this is somewhat of an edge case that we'd need to be careful doing in production. This is a way of basically updating a schema through a pipeline in a completely automated way. All I've done is I've had permissions to do a commit and push that commit, and the pipeline ran automatically and updated that. What we'll now do is update our web application to take advantage of the new blogs table. So if we refresh our web application here, this is our existing web app. We have a link to a blog page that goes nowhere. And in fact, the blog data is in the database, but we don't have a template or a view yet that will expose those comments and the blog functionality that we've just built. So what we'll do is put our developer hat back on again, and go back to our Git repositories that we've checked out. And what I've done here is I've already created a microblog branch. So if I look at the branches that I'm currently in Git, I'm in the age collection branch. What I'll do is I'll change to the microblog branch. And what this microblog branch contains is some presentation changes that we'll be able to start reading from the blog table, some application changes so that we actually can connect to the database and we understand the schema. And when we push this change and build a brand new discrete environment, we'll have two environments side by side, both reading from the same database, one on the previous version that doesn't understand the blog schema and can't display the blogs and the comments, and a new version which does understand and can display the blog. So all I need to do, I've already done this work by updating the application controller and the templates, and all I need to do is basically push this to GitHub. Now, what's going to happen in Bamboo is Bamboo will automatically discover the new branch. And so what I've enabled in Bamboo to do that is something called plan branching. So we've defined a data sources pipeline plan, we've defined a web application pipeline plan, and Bamboo will eventually see that we've created a brand new branch in our remote repository and basically branch this plan and run an identical version of it for our new change, and this will result in a new discrete environment. So this will take a little bit of time because what it's going to do is step through all of the stages that we've already talked about, one of which involves baking an AMI, which takes maybe 10 or 15 minutes perhaps, and then it will stand up identical infrastructure using CloudFormation so that we have two live web application endpoints. So we'll leave this for now. This will take a little bit of time, and we'll come back and look at how that's gone in about 10 or 15 minutes. Okay, so let's move on to the release phase. We've talked about deploy, and we've talked about the two different options for deploying our web application. The release phase is where we want to effectively switch on the new version of our application. And what we want release to let us do is test the new version of the app in complete isolation. We want to do some traffic matching between the two environments. We want to ensure that the new stack that we release is able to sustain the same load of the current environment. So you imagine in a production environment where we've potentially scaled out for variable load, we want to ensure that the new environment can sustain that load. And we're going to use DNS as the switch to turn on the new stack. This is a really easy, stateless way of turning on the new version of our environment. We could do things differently here. We could do it behind our load balancer if we needed a little more control. But for simplicity's sake, and in this case, DNS is appropriate, so we'll be doing that. Then we would send notifications potentially to teams of people to let them know that the release had been successful. And then optionally, we'd have a rollback phase. So let's think about that diagrammatically. Okay, here we have our BlueStack, which is our current production environment. Again, a fairly sort of trivial web application architecture here, just for demonstration purposes. Our current production DNS name resolves to our production load balancer, which then balances load to our Blue application version. What we do through the CI/CD pipeline is stand up a completely new environment, a new load balancer, a new auto-scaling group. We spin up new servers on EC2 based off our new AMI, which, remember, has had our web application change baked into it. And we can see here that that's been completed, but we only have two servers behind the load balancer. Now, if we were to flip the production traffic to that, those two servers would quickly become overwhelmed. So it's really important that we do traffic matching. So what we can do is, this is probably the most naive way of doing it, we could introspect the load balancer or ask the load balancer of the BlueStack how many backends it's balancing to. And we could do that via the AWS ELB API. And we would get an answer 4. And from our CI/CD tool, we could then say, okay, let's scale out the green stack to have 4 servers in it. Okay, that would be a fairly trivial and easy way to do that traffic matching. And maybe perhaps a more sophisticated way of doing that would be to look at the number of transactions per second going through the load balancer on the BlueStack and stand up an automated load testing environment to generate the same load that the BlueStack is seeing and point that at the green stack. Remember, green is completely isolated, and we can do that kind of work with no impact to our existing production environment. And then what that would do is let auto-scaling naturally scale out EC2 hosts behind the load balancer. We would warm the load balancer. If there were databases in the architecture, we could potentially be warming caches and doing a whole bunch of other work, which is perhaps a more thorough way of doing traffic matching. But at the very least, we could just make sure the same number of hosts behind the load balancer were there. To turn on the new environment, we update DNS, and we're using Route 53. Route 53 is programmable. It has an API. So we can update the zone file on Route 53 to point to the new ELB. And that can take some time to propagate around the world, so we need to be cognizant of that. But once that propagation is complete, we're then able to effectively tear down the blue stack. But let's say we've done due diligence, we've done our testing, and we still have a problem with the green stack. Rollback is as simple as updating the DNS record again and pointing back to the blue stack. And we can then either fix the green stack or tear it down and try again. So this is a really powerful roll forward, rollback mechanism as well. The final part of the life cycle was tearing down. So this involves steps like ensuring that there's no traffic moving through the ELB, and then using CloudFormation to tear down the entire stack in a consistent way. Once we've done that, we could even deregister the AMI. Remember, the AMI represents our application version. That's the artifact that we deploy with. So we could either choose to leave those AMIs there for version control and audit and reporting, or perhaps deregister to reduce storage cost. So what teardown would look like is we flip to our green stack. It's currently serving production traffic, and we don't need the blue stack any longer. So we could, again, using CloudFormation, and this could all be driven from our CI environment from Bamboo, for example, is tear down blue and effectively remove that infrastructure altogether and leave green as our new version. And then we effectively, the next time we release our web application, we do exactly the same thing, and we're basically rolling infrastructure stacks this way. Okay, so that's a discussion of the CI/CD pipeline. Behind the scenes, our pipeline is probably deploying our web application and probably making our AMI, so we'll let that continue. And we're going to talk in the remaining 15 minutes or so through some more advanced techniques that we're seeing emerge as best practices around how we do this kind of automation on top of AWS. We've already started talking about the idea of CD sprawl and the importance of tearing down our infrastructures when we're done with them. So we'll talk about some techniques and some ideas around how to manage that. We're also going to start talking about segregation of duties, and this starts speaking to that governance framework that we wanted to get to as well. We'll talk about how we can decompose CloudFormation templates for reuse and so on. We're then going to talk through a very powerful concept on CloudFormation called custom resources. And in fact, this is how we've implemented the database schema update that I just demoed. So we'll talk through that in quite a bit of detail. We typically use custom resources when we want to inject dynamic data into our templates, or if we want to manage a resource that CloudFormation doesn't naturally understand, for example, a relational database schema, or perhaps a service that CloudFormation doesn't currently support. So CloudFormation can be extended in really powerful ways using custom resources. And then we'll finally close with some thoughts around how we can extend our CI/CD tools and make them more aware of the infrastructure that we're running in our application environments. So the first idea about decomposing our templates for reuse is called stack chaining. And what I'm representing here is 3 different CloudFormation templates that each build a part of the infrastructure that represents an entire environment. So the first template here is responsible for building our virtual private cloud. It's responsible for defining and deploying the network topology inside of that VPC, and it's potentially standing up some supporting infrastructure here like an S3 bucket. It's important to remember that CloudFormation templates can accept inputs and generate outputs. And so what we can do is take the outputs of the first stack and chain them together and send them as inputs to the second stack, so that the second stack is responsible for building additional infrastructure using the information from the first stack. So here I may be deploying a Bastion host in a public subnet or a jump box. I may be deploying some backup infrastructure. I may choose to configure some CloudWatch alarms, and I might build a DynamoDB database for other supporting infrastructure. Again, we'll take the outputs of those 2 templates and feed them as inputs to the third template, and the third template completes the application infrastructure. So here we're deploying perhaps reverse proxies or load balancers in public subnets. We're deploying potentially application containers in a private subnet behind that, and maybe a highly available multi-AZ database on RDS using MySQL. Another approach to decomposing templates is to do something called CloudFormation Merging, and this was pioneered by one of our partners locally in Australia called Source Group. And the idea behind this is to take a single CloudFormation template and break that up into components. In the previous example, I had well-defined, self-contained, syntactically correct CloudFormation templates. In this example, I they just have snippets of templates that on their own don't represent full templates. And so what I'm able to do there is start breaking these snippets of templates into different repositories, and of course we're versioning these in our source code management system because CloudFormation is letting us configure our infrastructure and treat it very much like code. So what we have is an operations repository and an application repository. And in the operations repository, we have the snippets of CloudFormation that are responsible for building operational concerns, things like VPCs, security groups, CloudFormation frameworks, building the network topology and what have you. And in the application repository, we have templates that manage application concerns, things like how we bootstrap our application, how we configure application level load balancing, and other concerns that our application teams care about. And we can use access control on our Git repositories, and we can start thinking about separating roles and responsibilities across those and letting the right teams manage the right parts of our templates, but then use our CI tool here, Bamboo, to merge those templates together, and Bamboo would contain a master definition and would do a JSON merge of those snippets, and finally syntax check and output a valid, complete CloudFormation template. So let's have a look at custom resources. So custom resources allow you to extend what CloudFormation is able to manage. And so here we've represented architecturally how custom resources are implemented. We have CloudFormation as a service, we have SNS topics, and we have an SQS queue, and then we have the implementation of the custom resource inside an auto-scaling group running on EC2. So here, the first part of the lifecycle is a CloudFormation event, lifecycle event, and here we're representing a create event. Remember, CloudFormation can create and update and delete, and so the create event is going to pass some key value pairs to an SNS topic. That SNS topic will push that into a queue, and then our custom resource implementation will pull from that queue, consume that payload, so the key value pair, web app version 1.2 OS Linux, and basically perform the business logic or the custom resource implementation. In this case, it might be to query a DynamoDB database and get an AMI ID that's appropriate based on the key value pairs that we've pulled from the queue, and then it will return that back to CloudFormation. So this is a way of implementing a custom AMI lookup that we've stored in DynamoDB, rather than hard-coding an AMI lookup table inside of our CloudFormation templates, which most of you will have seen if you've seen any of our example templates. There is a way of simplifying this, so for those of you that are concerned with how complex this looks, I would absolutely suggest that you look at the CloudFormation resource bridge. It's open source and available on GitHub, and this simplifies passing the payload and exposing that in custom resource implementation as operating system environment variables, and also helps wire up these components together to simplify an implementation of a custom resource. This is what a custom resource looks like in CloudFormation. Here we're representing a custom database schema type resource, and inside of that I'm passing a database changelog with a change set, and the change set is passed as effectively the payload to the custom resource implementation. If you look right down inside this database changelog, I have a create table section, and the create table section here is defined to, it basically defines a table schema. Okay, so all this is doing is building a single column table with a primary key that's non-nullable and of type int. Okay, but the idea is that you do some much more sophisticated work than this, and in fact what we were doing in the previous example is using Liquibase and passing a change log to Liquibase, which is running on a custom resource that would then connect to our database and use Liquibase to update the schema. Okay, so extending our CI and CD tools is something that some of our more advanced customers need to be able to do. And so what we've chosen to talk about here is using Bamboo and tasks for AWS in conjunction with DynamoDB to enrich what Bamboo knows about our AWS infrastructure. So really what we can do is use something as simple as DynamoDB as a key value store to build some lightweight configuration management database. In fact, when we deploy our web application in Bamboo in the demo earlier, what we're doing is when we generate an AMI, we're writing that AMI ID and the branch and the version of the application into a DynamoDB table. And when we go to deploy that web application, we're using a custom resource to go and look up the right AMI and deploy that AMI to a complete discrete environment. So this is a way of using, say, the power of tasks for AWS and its integration with AWS to enrich what Bamboo knows about as far as our application level concerns. So let's have a look at our, let's go back to our Bamboo environment and just double check what our demo is doing. If everything has gone to plan, we should hopefully see a branch icon next to our web application pipeline. This branch icon represents a plan branch. So if we were to click on this plan branch, we can see a brand new branch that has been discovered. And remember, this was the microblog branch that we pushed earlier from our development environment. And if I go and click on that, I should be able to see a build running. And it looks like the build is still running. So let's just have a look at it. It's passed a unit test. That's good. It's built the AMI, and it's now releasing the application. So if we were to click on the release application stage and go to logs, we can see exactly what's happening here. We can see that a CloudFormation template is being used to deploy the application stack. And if we wanted to, we could jump back to the CloudFormation console here and have a look at the stack being deployed. So this was our existing stack that I showed you earlier. And this is our new microblog stack. And you can see that we've labeled things appropriately so we know which branch and which application we're deploying. And it looks like this hasn't finished yet, so that's okay. We can come back to that. But what we'll end up with is an output here, which is a URL for a brand new stack. And that brand new stack will understand our blog database change. So let's come back to that. Okay, so I think a meta point to make here is that what we're starting to do is, through automation and through enriching what our CI environment understands of our infrastructure and our application domain through plugins like Tasks for AWS, we're starting to move the burden of responsibility away from human processes to automation, and a really nice tight integration between our CI environment and the automation work we've done there and what our actual infrastructure is doing. This situational awareness is a key idea, I think, for a successful implementation of CI/CD. Another thing that we're starting to talk about is if you think about how we're deploying immutable AMIs that represent application updates to discrete stacks, what we're starting to do is we're moving away from the idea of updating environments with artifacts to the idea of building environments for our new artifacts. Okay, and this is a key point. So what we're starting to really change here is make our environments transient. We're not watering and feeding and caring for existing environments. An application environment only lives for the duration of an application version, and then we roll off to a new environment. And what this is giving us is a sort of a standard, it's standardizing the deployment approach, and I think it's also helping us achieve better portability. So I'm kind of mixing metaphors here, but what we've done by baking AMIs and deploying those AMIs to discrete environments is containerize the web application change and seal that up inside of an AMI. Now, there's some really interesting containerization technology that we're hearing about and a lot of our customers are looking at, one of which is Linux containers, and in particular, Docker as a framework for helping manage the life cycle of those containers. So I thought I should definitely talk a little bit about Docker. We've supported Docker in Amazon Linux for quite a while, actually, since I think March this year. But we've also supported Docker and the deployment of Docker containers on Elastic Beanstalk for a long time as well. And so you can right now today deploy Docker containers either on EC2 directly or deploy them to Beanstalk, where Beanstalk manages all of the underlying infrastructure for you right now. Okay, and that's pretty exciting, and we're really interested to see what our customers are doing with that. But perhaps more importantly, we've just released or just announced a brand new container service called the EC2 Container Service, or ECS. It's currently in preview, and what it's doing is providing basically the underlying cluster and framework to deploy Docker containers at scale. So rather than you having to manage placement of containers and schedule where they land on a given host, or a given EC2 host, the ECS service is managing that for you, and it's designed to scale to thousands, tens of thousands, potentially even in excess of 100,000 containers on an ECS cluster. It supports Docker currently, and the containers are deployed within your VPC, within your virtual private cloud on EC2. It helps manage the container lifecycle, and it also has an implementation of a scheduler that can place containers appropriately in your cluster. So to reiterate the main takeaways today, I think what we've really talked about is a number of different techniques and approaches to improve our ability to innovate as teams. So we've talked about the branching model. We've talked about containing the risk of experimentation within the branching model. If we couple that with the idea of deploying changes to brand new, discrete, isolated environments, then we're removing the risk that a change can impact an environment we care about. And this can dramatically empower our development teams to try new ideas and to experiment and to innovate. We've automated testing largely as much as possible. We've shown some very simple unit tests, but we could do all sorts of testing. We could do code analysis tests, security tests, load tests. We could even simulate users through Selenium environments that we spin up automatically in our pipeline and so on, with the idea that we're slowly improving quality as we iterate on our applications. And we've talked about audit trails and logging and segregation of duties and separation of roles and responsibilities as a way of starting to manage the change and the speed of change that we can push through an automation environment like this. And I think that can help build a really compelling governance framework as well. So that's all I had today. I'd remind everybody that we have some really good online training, and that online training is available for you as a self-paced lab. We also have instructor-led classes, and if you need to learn about those, please visit our training website, which is linked here. And once you've done some of that training and you've been through some of those instructor-led classes, I would really encourage you to have a look at our certifications as well. This is becoming quite widely recognized in the industry and can help validate the experience and the knowledge that you've gained through that training and be recognized by your peers as well. Thanks for attending the webinar today. I appreciate an hour is a lot of your time. I hope you've learned something from it. We would love to get feedback from you, so please don't forget to complete the survey and tell us how we can improve these in the future. And thank you very much for your time.